rolling resistance. Deformation at the point of contact between a rolling wheel and its supporting surface introduces a resistance to rolling. At the point of contact between a rolling wheel and its supporting surface. Introduce a resistance to rolling which we mentioned only briefly. This resistance is not due to tangential friction force and therefore is an entirely different phenomenon from the direct friction. To describe rolling resistance, we consider the wheel shown in this picture under the action of a load L on the axle and a force P applied at the center to produce rolling. The deformation of the wheel and supporting surface as shown is greatly exaggerated. The distribution of pressure P over the area of contact is similar to the distribution shown. The resultant R of this distribution acts as the sum point A and must pass through the wheel or center for the wheel to be in equilibrium. We find the force P necessary to maintain rolling at the constant speed by equating the moment of the all forced about A, lemma A, this point, P, or indeed where the moment arm of P is taken to be R, the ratio mu R, A on R is called the coefficient of rolling resistance. This coefficient is the ratio of resisting force to the normal force and thus is analogous to the coefficient of static or kinetic friction. On the other hand, there is no slippage or impending slippage in the interpretation of the mu R. Because of dimension R depends on many factors which are difficult to quantify, a comprehensive theory of rolling resistance is not available. The distance A is a function of the elastic and plastic properties of the matting materials, the radius of the wheel, the speed of travel, and the roughness of the surfaces. Some tests indicated that A varies only slightly with the wheel radius and thus A is often taken to be inadequate of the rolling radius. Unfortunately, the quantity A has also been called the coefficient of rolling friction in some references. However, A has the dimension of length and therefore is not a dimensionless coefficient in the usual sense. This is the end of the chapter 6, friction.